Hello and welcome everybody. Today is the day 19 of our Smart 25 Days Challenge, and today we are going to make our land registry smart contract. Although this is going to be a very simple explanation and a simple implementation, but this will help us understand how smart contracts can be used for the purpose of land registry, and we would also see the implementation of internal functions. And although I have covered them in previous videos also, but today also we will be using and just polishing our smart contracts writing skills. So let us get started. So first of all, let us make our file called as land registry. Then okay, looks cool. And then just write contract called as land registry. Okay, so first of all, as we all know, for a land registry, the main thing is the piece of land. Okay, so we need to keep the details of that piece of land at one place, and we would be storing that into a struct called as land. And then in that struct, the properties would be address of the owner and the string of location. It could be used for storing the coordinates. Okay, and a unit of size. Okay, for size, how much square meter of the units which ever it is. Okay, for how much square meters, let us assume that to be in square meters. How much square meters is the piece of land? And then for that, for storing the records of the for associating the owners with their land IDs. Okay, for basically associating the lands with the specific something such as like land ID, we need a mapping. Okay, so for associating the lands with some land IDs to identify them uniquely, we would be using mapping called as land records, and in this we would be using. Okay, this bytes 32 is the land ID. Okay, a CAC 256 as we have generated in the previous videos also. Okay, we would be using a CAC 256 hashing function to generate a hash, and that would be the two byte of 32 bytes. Okay, so if you guys have any confusion or are not able to follow what I am teaching, so please I would recommend you to go through my previous videos so that you may know everything in detail. I have covered everything in detail. So please go through there. And after this mapping, we would be so now we would be creating two functions and sorry, not functions, two events. Okay. And the events would be first of all land registration, and the second event would be for the transfer of ownership. Okay. So let's make it land registered bytes 32 indexed by land ID, address indexed owner, string, location, then unit size. Okay. Another event would be the transfer of ownership. So we'll call it ownership transferred. To from also. Okay. And two. So that means that from which address to which address we are transferring the ownership, and clear in itself index 2. Okay, looks fine. So now let's make the function to register the land. Register land. Okay, unit land ID, string, memory, location, then unit size. Public. Okay. Bytes 32. So from the user, we have taken the land ID in the form of a unit like 1, 2, or 3, or 4. Okay. And now we would be generating a 32-bit hash, a 256, not 32-bit, 32 bytes. Okay. So 256 bits by using the keycag 256 hashing algorithm. And land ID, and we would be using an internal function called as generate land ID for this purpose. And land ID, and that function we would be defining later on. So land ID, yes, looks cool. And the required condition would be that the land should not be registered. So you would be checking that by accessing the land records mapping, and so by retrieving the land struct associated with a particular land ID or owner. Okay, uh, should be a zero address. Then only we will say that it's not yet registered, and otherwise we would say that the land is already registered if the address is not a zero address. If the land is associated with some address, so we will be saying that land already registered. I guess I am very much clear in this step. There is no confusion. So we are basically just checking. Okay, we are accessing the land records mapping by using the land ID, and with that specific land ID, we would be accessing the land struct associated with that particular land ID. And in that struct, we are accessing the owner property dot owner and checking that it should be a zero address. Okay, a zero address. That means that this land the piece of land associated with that particular land ID is not associated with any address. Okay, that means that there is no owner of that land currently. So, why we are checking that? Because this is the first time we want to register a land, and if it's already registered, so we will be saying that land has been already registered. Okay, land already registered. That's it. And so after checking the required condition, we would be moving on, and then we would be creating a land struct. Okay, memory. And so basically, okay, we'll call this new land, and this is the constructor which we are calling. And then for the properties, we are assigning the values. Okay, for address, for the owner's address, we would be calling sender, and then location and size. And land records, land ID, new land. Okay. So basically, what we have done here is by calling this, this is the constructor, and we have what we have done. We have basically made this. Okay, wait a sec. Still memory location. Okay, yeah, looks fine. And so basically what we have done here is we have stored created this by using this we have created a new struct and stored that into a variable called as new land. And then in by using the land ID, we have associated that new land into the land records mapping with that land ID. Okay, in the land records mapping, we have associated this newly created new land struct with the particular land ID. Okay, I hope I'm very much clear in this. So if you guys have any doubt, then please ask me out in the comment section. Otherwise, you can reach out to me on Twitter and LinkedIn also. So then we would be meeting the event land registered. Okay. And in the land ID, okay, message dot sender would be uh, owner. Okay. And then location and size. Okay. Passed by the user in this function. And that's it for this. We have emitted that. So, okay, our function to register the land is now complete. And now we would be moving on to our second function, that is to register, so to transfer the land. Okay, transfer ownership. For registering, we have done function to transfer ownership, point, land ID, address to that's public, rights to and ID. Okay, again using our internal function to generate the land ID. Land ID looks fine. Okay, checking the required condition that the person who is transferring the owner should be the current owner only, and no one else can just transfer the ownership on someone's behalf. Okay, and I dot owner equals to message dots. So basically just we are accessing the owner property. Okay, and we have retrieved the land struct associated with a particular land ID and then access the owner property to check whether the owner of that particular land struct is the message dot sender only or not. And if it's not so, so we would be just saying that only only the owner can transfer ownership. Can transfer ownership. Okay. Yes, looks cool. And then just okay. So now when this is done, so we want to just okay make changes to the already existing land struct in the storage lands, and so we would be retrieving the land struct by using the land records mapping. Land records land records mapping this by the particular land ID, land struct associated with the particular land ID. We have just retrieved that. Okay. And why we have used the storage keyword? Because we want to make changes to the already existing land struct associated with that particular land ID. And we have just stored the value retrieved from here. Okay. By accessing the land records mapping and by retrieving the struct associated with the particular land ID, we have stored that value into this lands, okay, with this variable, land variable, and this is of the type land only, okay, land struct, this land, this land, this is the type, this is the struct, okay, so land data type of the struct, because here also we are retrieving a struct only, so that's it. Okay, I hope I'm very much clear in this land records mapping, as you can see. Okay, so with the we are retrieving what we are retrieving here. We are retrieving here the land struct associated with the particular land ID. Okay, and storing that into a variable called as small l and a and d. And then what we would be doing is, so we would be making some changes to it and just address previous owner. Yes. So the line, yeah, owner equals to land dot owner, and now we would be changing the landowner to be land dot owner to the to address. Okay, and now we would be just emitting the ownership transfer uh, event, and land ID will be this only and from, and this from would be the previous owner. Yes, owner. Yeah, and then this two would be this. Okay, the two address passed by the owner, the user. And that's it for this function also. And our function to transfer ownership was also complete. And now let's just make a function to retrieve the details, land details. Function get land details is int land ID. Just provide the land ID. Select view returns address owner and memory location viewing size. And then just again the same thing. We can just using our generate land ID, land ID internal function and just passing this land ID to it. Okay, and range. Suppose we want to know the details, records, and in that land records, just access and retrieve the struct associated with the particular land ID. Okay, require that the land owner should not be a zero address. In this zero, otherwise we'll save land not just if everything goes well, then just return land dot owner, land dot location, and land dot size. Okay, looks cool. So it's time for the final function that is going to be our internal function called as generate land, which we are using but we have not yet defined. So let's define it. Okay, so this generate land function, we would be now defining it. Land ID. So we'll be taking land ID internal your function that is returns. Okay, it's and this function would just generate the hash and return. We get 256 ABI dot encode tag basically land ID. That's it. So looks like our whole smart contract is now complete and we can now just check it out. Okay, so let's just compile it and see, and let's try to just deploy it, compile and deploy, and let's test it out. Okay, so let's deploy it. It's successfully deployed. Okay, so now say someone wants to register a land, so he may just by checking the chart by the concerned authorities, this can use this, or they can just provide, say, let us say the land ID is one and location maybe say the coordinates. Okay, so so the coordinates can be anything such as like 1 point something or something like this, and uh, 3.2 and all. Okay, so the size may be 50 or something or whatever. Okay, 50 square meters just for now, and let's see. So to getting for getting the details about this, anyone can check. Okay, the owner of this land is this address C4. And you can check. And this is the owner, and the location is this these coordinates, and the size is 50 square meters. So this is, although this is a basic implementation, but you must have got an idea about what this smart contract is doing and how we can use smart contracts in the land registry purpose. Okay, so that's it from my side, guys. If you guys have any doubts, then please ask me out in the comment section. You can always add some other functionalities to it if you want. You can test it out, you can play with it, you can add some more functionalities to make it a better version. And see you on day 20. Till then, bye bye.